So Unit 1, Introduction to Signals and Systems. So first we will see what is signal and what is system. So in our daily life we use the word signals, which is very common. For example, mobile signal, TV signal, radio signal, etc. Basically, the signal is a physical quantity and it changes with respect to some dependent or independent variable. So the definition of signal is: a signal is a physical quantity which varies with one or more variables and carries some information. For example, the acceleration of the car, sound, pressure, voltage or current of the circuit, the electrical activity of heart, that is ECG, etc. Now, what is system? So, a communication system is basically used to transmit and receive some message signal. So there are some major blocks of communication system, that is transmitter, channel, receiver. Suppose we want to transmit a message from one point to the another point, that is from transmitter to receiver. Usually transmitter and receiver are far away from each other. A message signal is not in the proper format, so it cannot be directly sent as it is. A message signal can be audio signal or data from computer. The transmitter is a device which converts a message signal into required format so that it can be easily transmitted. The output of transmitter is passed through the channel. Now, channel is a physical device like coaxial cable, audio cable, fiber optic cable, etc. When the signal is transmitting through a channel, noise is added. That means received signal is distorted. So the function of the receiver block is to reconstruct the distorted signal. It is also called as a estimation of the signal. So what is control system? The major blocks in the control systems are the controller, plant and feedback sensor. The system which is to be controlled is called as a plant. A plant can be air conditioning system, electric motor, room arm, etc. Robot arm, etc. The noise is added in the output of the plant, so output is deviated. This output is feedback to the input side. A feedback sensor is used to convert the output into equivalent electric signal. This is because the output of the plant can be any physical quantity and not necessarily an electric signal. The summer used at input side compares feedback signal with reference input signal. The difference between the two signal is called as error signal. Then the error signal is applied to the controller, and the function of controller is to generate a control signal. The control signal is then given to the plant, and this control signal is generated in such a way that the error signal is minimized. So first is introduction to signal. In electrical engineering, the fundamental quantity of representing some information is called a signal. It does not matter what the information is, analog or digital. In mathematics, a signal is a function that conveys some information. In fact, any quantity measurable through time over a space or any higher dimension can be taken as a signal. A signal could be of any dimension and it could be of any form. Any physical quantity that carries some information can be called a signal. The physical quantities like temperature, pressure, humidity, etc. are continuously monitored in process. Usually, the information carried by a signal is a function of some independent variable. For example, time. The actual value of the signal at any instant of the time is called its amplitude. These signals are normally plotted as amplitude versus time graph. This graph is termed as the waveform of the signal. The signal can be a function of one or more independent variables. Let us now define a signal. So the definition of signal is: it can be defined as any physical quantity that varies with one or more independent variables. So let us consider the temperature measurement in a plant. The measured value of the temperature will be its amplitude. This temperature changes from one instant of time to another. Hence, it is a function of time which is an independent variable. As it does not depend on anything else, the temperature can be measured at two different locations in a plant. The value of the temperature at two different locations may be different. Hence, the temperature measured depends on the time instant and also on the location. We can say the temperature is a function of two independent variables, namely time and location in a plant. This temperature can take on any continuous value like 30.1, 30.00, 132, 12, etc. The time axis is also continuous, that is, the temperature is noted at each time value. The signal is then called continuous time, continuous amplitude signal. So continuous time signal, it is the variable of time. Here the variable of time is continuous. A speech signal as a function of time is continuous time signal. The discrete time signal, the variable of time is discrete. The variable of time is discrete. The weekly Jones stock market is an example of discrete time signal. So here the graphical representation of continuous time signal and the graphical representation of discrete time signal is shown here. So continuous means here the signal is continuous with respect to time. A continuous time signal, it has a continuous amplitude and time. It is the signal which is defined and represented at any instant of the time. So a CT signal, that is continuous time signal, is denoted by x of t, and t is the variable which represents the time and x represents the shape of the signal. And the DT signal, that is the discrete time signal, is abbreviated as a DT signal. It is also called as digitalized signal. It has amplitude values only at discrete instant of time. So its definition is, it is a signal which is defined and represented only at certain instant of time. So DT signal is denoted by x of n, where n is a variable similar to time and it is used to represent the discrete signal, where x represents the shape of the signal. The DT signal is also called as a sequence of samples, and this signal is obtained from the CT signal, that is continuous signal, by performing the sampling. The signal which is discrete in time as well as discrete in amplitude is called as digital signal. To distinguish between the continuous time and discrete time signal, we use the symbol T to denote the continuous variable and N is to denote the discrete time variable. A discrete time variable Xn represents a phenomenon for which the independent variable is inherently discrete. A discrete time signal Xn may represent the successive sample of an underlying phenomenon for which the independent variable is continuous. For example, the processing of a speech on digital computer require the use of discrete time sequence representing the values of the continuous time speed signal at discrete points of time. So, the discrete time views the values of the variable as occurring at distant, separate points in time or equivalently as being unchanged throughout each non-zero region of time, that is time period. That is, the time is viewed as a discrete variable. Thus, a non-time variable jumps from one value to another as time moves from one time period to next. This view of time corresponds to a digital clock that gives a fixed reading of 10.37 for a while and then jump to a new fixed reading of 10.38, etc. In this framework, each variable of interest is measured once at each time period. The number of measurements between any two time periods is finite. The measurements are typically made at sequential integer values of the variable time. A discrete signal or the discrete time signal is a time series consisting of a sequence of quantities. So there is a reason for using some standard state signal. Basically, the standard state signals are used for the analysis of system. These signals are also called as the elementary signals. Such signals are used as a basic building block for the designing of complex systems. These signals are used to model many physical signals. In control system, these signals are used to give the indication of sudden change in the input signal. Such signals are used for the analysis and designing of control signal. So some of the standard continuous time and discrete time signals are DC signal, unit step signal, sinusoidal signal, signum function, sine function, sync function, triangular place, etc., pulse, etc. So first signal is unit step function or unit step signal. The unit step function is denoted by u of t and it is defined by u of t is equal to 1 for t greater than 0 and this value is 0 for t less than 0. This is for continuous time signal. The unit step signal is shown here. It has a constant amplitude of unity means 1 for the 0 or positive values of the time, but it has a 0 value for the negative values of the time. The unit step signal is mathematically represented by ut equal to 1 and 0 for t greater than 0, t less than 0. It is used as a best test signal. Area under unit step function is unity. At t is equal to 0, the amplitude of signal suddenly changes from 0 to 1, so it is called as unit step. This is all in CT signal. Now in DT signal, a discrete time unit step signal is denoted by u of n and its value is unity, that is 1 for all positive values of n and for n equal to 0. That means its value is 1 for n greater than equal to 0 and for negative values of n its value is 0. So unit step response, the unit step signal has amplitude of 1 for positive value and 0 for negative value. It has two different parameters such as CT unit step and DT unit step. So next is unit impulse function. Unit impulse function. Or it is also called as a delta function. So impulse function is denoted by delta of t, where delta t is equal to 1 for t equal to 0, and for t greater than 0, t not equal to 0, its value is 0. So here dt is equal to du of t by dt. So in continuous time delta function, it is denoted by delta t. The delta function is shown here. It is present only at t is equal to 0. The width of the signal tends to 0 to its amplitude at t equal to 0 is infinitely large. Thus area under the pulse is unity. Since area is unity, it is called as unit impulse function. So now in dt, that is discrete time delta function, it is denoted by delta of n, and its amplitude is 1 only for n equal to 0, and for all other values it is 0. So the amplitude of unit impulse approaches 1 as the width approaches 0, and it has a 0 value at all other values. It is used to determine the impulse response of the system. An impulse function is a special function is to model a certain events. Impulse function is not realizable. The output of the impulse function is usually infinity at certain values. Most important property of impulse function is shifting property, as it effectively samples the value of the function f at the location a, and this is used to sample continuous function into discrete values. Using this property, we can extract a single value from continuous function by multiplying with an impulse and then integrating. Next is ramp signal. So ramp signal is denoted by r of t, and it is defined as rt is equal to t for t greater than equal to 0, and it is 0 for t less than 0. Now area under unit ramp is unity. The amplitude of every sample is linearly increased, and the positive value of the independent variable. So in continuous time, the unit ramp is denoted by r of t. At t equal to 0, amplitude of the signal is 0. At t equal to 1, amplitude is 1. Now at t is equal to 2, amplitude is 2, and this amplitude of the signal is same as that of the value of t. Now in discrete time unit ramp, it is denoted by Rn. Similar to Ct unit ramp signal, its amplitude is equal to the value of n. So in dt unit ramp, it is denoted by Rn is equal to n for n greater than equal to 0, and it is